Hello folks, greetings. Hope you all had a good day. I had a good day at work too. And as I promised, I actually created a return format of the mind map of all the things that we learned about antiderivatives so far. And if you look at the previous video, there is a link to it where there is a picture of what I did on plain paper, right? Again, with math, one of the things that you got to learn is don't be very conservative with paper. Okay, you can waste a lot of paper. The point is, the more and more you actually do it with pen and paper, is how much you'll remember. Now, with math, again, I don't like to use any digital devices, right? Just use pen and paper. Write it down and write it down, then you will get it better. Okay. So that said, today what I'm going to do is that I'm going to go through some of the exercises, and the book that is provided as excellent set of exercises that it's looking at. And the exercises basically comes from the concepts that's been taught to us throughout whatever we learned so far, right? There's like 4 or 5 formulas. You put 1 and 1 to 2 and 3 together, 4 and 5 together, and come up with solutions for it. Okay. And what I planned is I'm going to do some of it. I'm going to skip some of it so that you can practice. Right. I'm not going to solve all the problems here. I'm just going to solve some of the problems, and then I'm going to let you solve some more problems. Okay. And I'll try to take some complicated or some twisted questions, and I will try to, I don't think there's a lot of problems that's given here. I don't know if it is going to be fitting in one video, but I can put that in more videos. Okay. Okay, so that said, just follow this through when you are doing these problems. Just follow what I'm trying to do it. Okay. So let's go and look at the first problem. Okay, it says find the antiderivative of, and they give you a function. Now you got to understand, when they ask you find the antiderivative of, and when they give you a function, what they are saying is dx by dy is whatever that function is, you got to find y. Okay, so make that assumption. So let's take the first problem, the exercise 4.07. I'm taking the first problem, which is, hey, find the antiderivative of 2x minus 3. Okay. So let's go to our, let's see, blackboard. And in the blackboard, I am going to see, okay, so there is a problem. It says, you know, find the antiderivative of 2x minus 3. Okay. Now there are various formulas that was provided to us before, and I'm going to list some of them here so that you can get to what I'm trying to get to. Okay. So the first formula that was given to us is, and I'm going to list all these formulas. One formula is, and I don't know if I need to, let me see, let me do this. Let me put it in the side. Okay. So the one formula is that we know that if d, what happened? Okay, white. Okay. If dy by dx equals f of x plus g of x, then we said, hey, you know, the way to find antiderivative is you find the antiderivative of f of x of the function, the first function, then find the antiderivative of the second function, and then add a constant. Okay, that is one concept. The other concept that can be used here is that we know that when, and I'm going to write this down, And I'm going to write this down here somewhere. Let me see. Okay, I'm going to write it down. If this one is like if dy by dx equals kx to the power of n, then y is actually kx to the power of n plus 1 divided by n plus 1 plus constant. Okay, we know that. And then there's one more problem that was given to us, which is basically, so I'm just going to put these as for these are all formulas that was given to us long before. Okay, and then there's one more thing. Again, I don't want to mention this again and again, but at least for the first problem I want to mention it. It's if dy by dx equals k, then y equals kx. Okay, so if given all these problems or given all these formulas, okay, now they're asking, hey, what is the antiderivative of 2x minus 3? Now, first of all, if you see 2x minus 3, it has two terms, so that means it is in the form of f of x plus g of x. So if you have that kind of form, then you find the antiderivative of 2 of x and antiderivative of minus 3, right? And then you add a constant to it. Okay, so you got that. That's the first formula. The second one sounds like, it looks like if dy by dx is constant k x to the power of n, then you have a formula. Now you see that you already have a constant 2 x to the power of 1, right? So you have that. So let's find the original function for antiderivative for 2x. That will be 2 x to the power of 1 was already there, so n is 1, so 1 plus 1 divided by 1 plus 1. Okay, that is the first derivative. Obviously there's going to be a plus c, which is a constant, but I'm just going to ignore the constant, and then I'm going to look at 3. So dy by dx is k, then it will be kx. So if it is minus 3, it will be minus 3x, right? So that will be minus 3x. Then we add the constant. Remember that when we are adding too many constants, you don't have to have constant plus constant plus constant. You just put one constant. Okay, so we have that. Then obviously that 2 and that 2 will cancel out. So this is actually going to be x square minus 3x plus c. And that is the answer, right? Now, one of the things I did in this first problem is that I went really slow. I went step by step. I also reminded you of all the formulas that I used. Now, of course, that you don't have to do all these steps, but it's better to start. When you start doing these, just put all the formulas together. I'm not sure if you have a test where somebody is going to give you all these formulas, right? So when you keep writing these formulas together, you will remember it. You will kind of memorize it, and then you can go and solve the problem. Okay. So hopefully this problem is clear. It's not a complicated problem, but I just want to take it as a warm-up. Okay. Now let's look at one more problem. I'm going to clear the board. Go back to the book, and I'm kind of going to skip this next problem, x squared plus 8x plus 1, because now that you know how to do 2x minus 3, you can also do x squared plus 8x plus 1 is my assumption. But what I'm going to do is I'm going to take the problem C, which is x to the power of 5 minus 4x cubed, right? Again, in this case, I don't know why I'm going to this page all the time. Okay, here you go. Why is the online board white in color? Okay, that is interesting. Let me reset the board. Let me reset it. Maybe I pressed something that caused the problems here. Well, if it is a whiteboard, it is a whiteboard. I don't know why it suddenly changed to whiteboard. So I'll use black color, okay? Okay, so the second problem was x to the power of 5 minus 4 x cubed, right? And now we know the rule where you have two derivatives. You need to find the antiderivative of the first term and then antiderivative of the second term. The antiderivative of the first term is very simple. It's x to the power of 6, which is n plus 1, and then divided by n plus 1, which is 6, okay, minus, now we got to keep the 4 there, then it's going to be x to the power of 4 divided by 4, right, n plus 1 divided by n plus 1, and then you get plus c. And this 4 and 4 cancels out, so this is going to be x to the power of 6 divided by 6 minus x to the power of 4 plus c, and that is the answer. Okay, so that one was simple. Let's look at one more problem. So again here, let me do x minus 1 the whole square, because this is the first time you're looking at something like something minus something or something plus something the whole square, right? X minus 1 the whole square. So let's look at that problem. Let me clear or create a new board. No, I can clear it. Okay, clear the board. Yes. Okay, so now we're going to look at this. Find the antiderivative of x minus 1 the whole square, right? Okay, now you do remember that we did have a formula, and I'm going to write that formula down here. If dy by dx is ax plus b the whole power n, then that is equivalent to ax plus b whole power n plus 1 divided by a multiplied by n plus 1 plus c. Okay, you have that formula, and so here it looks like 1x minus 1 the whole square, right? So it looks like a is 1 and b is minus 1 and its n is 2. Okay, so it's a very simple formula. So then we apply that formula. We say that, oh, that is equal to ax plus b, that is in this case it's x minus 1, the whole n plus 1 is the whole cube, divided by a is 1, remember a is 1, of course we don't mention 1, and then n plus 3 is 3. So it's x minus 1 the whole power 3 or cube by 3, and then don't forget the constant, okay, plus c. So that's how you do that problem, right? Okay, so now let's clear the screen, and I can close that, and let me go back to the book. Now let me try to solve one more problem, and I'm just going to solve this problem of E, okay? This is 6. What will you do? Correct? So let me go back to the blackboard, or the whiteboard in this case. And the question is, hey, what if you are given, what is the antiderivative of 6? Okay. Now remember that we had this thing where we say that, hey, if dy by dx is equal to k, then y is equal to kx plus c. Okay, so that is the formula given to us. So this will become 6x plus c, and don't forget to put the plus c because it can be a constant. Now you might ask me that, hey, why is that there is a plus c, right? And again, I want to remind you that the way you can find if this answer is right is you just try to find the derivative of 6x plus c. Now what is the derivative of 6x plus c, right? It's going to be 6, and since x is to the power of 1, you just put multiplied by 1, and 1 minus 1, right? Correct? And then the constant c, when you differentiate that, that's going to be 0. So now what happens? This is actually 6 into x to the power of 0, and that becomes 6. So therefore, and that is okay. So therefore, that if you gotta have c could be a 0, but I'm saying you still have to have c. So that's the right answer. Got it? Okay, now let's see if we can pick up something more complicated. Clear it. Then I'm going back to the book. I'm looking at the problem G. I know that because I put x minus 1, the whole square, it's easy for you to get 3x plus 2, the whole, is that to the power of 5? 3x plus 2, the power of 5, right? Now, I think you can solve the problem. If you can't solve the problem, I'll try to solve the problem, and then if you can't do it, come back to me, okay? I think you can do it because it's of the form, again, the hint I'll give you is that if dy by dx is ax plus b the whole power n, then you got to find ax plus b, n plus 1, so that is 3x plus 2, it is power of 5, it will become 6, divided by, the only thing that you got to remember is in this problem, a was 1, in this problem a is 3, so it's 3 into 6, right? So it will be 3x plus 2 to the power of 6 divided by 3 multiplied by 6, which is 18, right? That will be the answer for that one. So you get just try it. I even gave you the answer. Try it out, okay? I'm just going to skip to this more complex problem, which is 8 multiplied by 2x minus 7 to the power of 4. So let's go and see how we can solve this problem, okay? Going back to the whiteboard. So the problem is that you have, find the antiderivative of 8 multiplied by 2x minus 7 to the power of 4. Now, if that such a problem is given, you got to, so many times what happens is you got to be clear with the concept, you got to understand the formula, and then what you do is that you kind of find out, okay, this looks like what pattern, right? This one looks like, the pattern looks like the general chain rule that we studied, which is if dy by dx is equal to f prime of x into f to the fx to the power of n. Then we say, okay, if it is of that form, then I do fx to the power of n plus 1 divided by n plus 1 plus c. This was the formula that was given to us, okay, if you remember. So, but we got to figure out, okay, is 8 like f, the derivative of f of x, right? First of all, we need to find out what is f of x. And based on this formula, f of x is equal to 2x minus 7, okay? Now then, of course, you can find the derivative of x, f dash of x or f prime of x is what? You find the derivative of 2x minus 7. So derivative of 2x minus 7 is 2, and derivative of x is multiplied by 1 x to the power of 1 minus 1, and when you get the derivative of minus 7, that's 0. So that is 2 into x to the power of 0, which is 1. So therefore, f prime of x is 2. So f prime of x is 2, f of x is 2x minus 7. So what happened? This is what happened, right? What happened is that the above equation, you got to write it as 4. Okay, there is a 4 multiplied by 2, which is the f prime of x, and then there is a f of x to the power of 4. That's how it looks like. You see that? So therefore, and then you can also see that this is like, 4k, and then the derivative, the antiderivative of a function, right? So what you can do is, so that is equal to 4 multiplied by f prime of x is 2, correct? And then f of x is f of x, which is 2x minus 7 to the power of 4, right? So if situation is like that, then you use the above formula. So that means that is equal to, take the 4, you can ignore the 2 because that is the f prime of x, and then find a f of x to the power of n plus 1. So that is equal to 2x minus 7 to the power of 4 plus 1, right, to the power of 5 divided by 4 plus 1, which is 5, plus c. Okay, and that is obviously the answer. So when you get these kind of problems, what you need to do is you need to take this function, find its derivative, and that derivative is all you can have. So if you have a constant here, you could take just that derivative, but after that, whatever the rest is remaining, that should be just a constant, okay? And then you find the answer. Okay, so so that's the kind of problems that we have, and I kind of finished off 1, right? Now, the second one, instead of saying find the antiderivative, all they're saying is find f of x if f prime of x. Okay, it's the exact same thing, right? So therefore you can use the same exact formula, right? Now if f prime of x is 6x squared minus x, then you say you apply the same formula. It is 6x cubed by 3 minus x squared by 2, right? You see that? That's kind of how you solve the problem, okay? And so I'm pretty sure that you can solve this problem, you can solve this problem, you can solve this problem without any issues, okay? Now there are two other problems which is little hard to solve. One is that you have this thing where it is x plus 1 and x minus 3, okay? So that one is little complex because you have two terms, right? Now one way to solve that problem is very easy because you just do the multiplication. You say hey, x plus 1, in fact, why don't I solve that problem? X plus 1, x minus 3, okay? I'll solve it and show it to you. It should be easy, but I'm just going to solve it. That is 2D, okay? X plus 1, x minus 3. So I'm just going to clear the board. So I'm just going to put x plus 1, x minus 3, right? I want to make sure that that is the problem. X plus 1, x minus 3, okay? Now, the best way to solve this problem is, one, it could sound like, hey, is it f prime of x multiplied by f of x? I don't think so, because f prime of x is different, right? Instead of going through all those things, just use normal algebra. You do x plus 1 multiplied by x minus 3 is what? If you multiply, it's x squared minus 3x plus x minus 3, correct? And that is equal to x squared minus 2x minus 3, okay? So you got the thing. Now find the antiderivative of x squared, right? Antiderivative of x squared is of the formula x cubed divided by 3, okay? Minus 2 into x to the power of 1, so that will become x squared divided by 2 minus, here it is 3, so if it is a constant then it becomes 3x, and then ultimately you add a constant, okay? And then that is equal to x cubed by 3 minus x squared, because 2 and 2 cancels off, and minus 3x plus c, okay? And that should be the answer for, and by the way, this book does contain the answers, so you can take a look at the answers and verify it. So this is for the second question, D, right? And if you go and verify the answer, it looks right, okay? So sometimes you just use plain algebra to solve the problem, okay? Now I'm going to solve one more problem, which is that x to the power of 1 by 2, right? That's again very easy, but let's see, because they're just testing your basic algebra knowledge, okay? So x to the power of half, let's do this, clear the board, and they're saying, hey, find the antiderivative of x to the power of half. We blindly follow the same exact formula, okay? That is equals to x to the power of half plus 1, correct? Divided by half plus 1, right? Now, you just need to do your basic, you just need to know your basic algebra or arithmetic in this case. So, half plus 1 is 1 plus 2 divided by 2, correct? Because 2 becomes the common denominator, and that is equal to 3 by 2, right? So they are saying that is equal to x to the power of 3 by 2 divided by 3 by 2, and that will be equal to, because if you divide, it becomes upside down, so it will be equal to 2x to the power of 3 by 2 divided by 3, and that's your answer, right? And 2x to the power of 3 by 2 divided by 3, and the other thing that I'm always forgetting, and you should never forget, is plus a constant, okay? That's the answer. Okay, so you got it, right? So sometimes when they are tricking you with an algebraic or an arithmetic question, you just answer with an arithmetic answer, right? So now they are going to the third. If you look at the third question, they are saying x plus y in terms of x. See, first one they said I find the antiderivative. Second one they said I find f of x given f prime of x. Third one they are saying I find y in terms of x, which is again an antiderivative, right? Again, what you do is you apply the exact same formula, okay, for each one of these items. Now, I do see that sometimes they are giving you, all of this is not at all complicated, right? So there is 5x to the power of 4 minus 9, you will solve it, because we already did. Something is of minus n, you still have to use plus 1 and plus 1, and so you can solve that. Then if it is a fraction, then 1 by 5 is a constant, then you can solve that. I'm going to talk about this problem, the dy by dx equals 2 divided by x square, okay? I'll tell you how to solve the problem, it's very easy. Next one is x cubed minus 2 by 3x plus 1, again, 2 by 3 as a constant k, and you can solve the problem, okay? So I just want to show you the third problem, D, is they're asking 2 by x square, right? So let me go back to 2 by x square, okay? I'm going to solve that for you because it's little, they're just tricking you, right? What was that? 2 by x, trying to make sure, x square, 2 by x square, okay? So they want you to solve 2 divided by x square. You got to find the antiderivative, okay? Now this is actually very, very easy because this can be expressed as, you may say, oh, what's going on? This can be expressed as 2 to the power of x to the power of minus 2, right? You put the x up. This is square, but if you put it up, it becomes x to the power of minus 2. I'm just giving you an example. When somebody says, hey, 1 by 100, that is actually 10 to the power of minus 2, correct? That's what I'm coming to, right? And once it becomes 2x to the power of minus 2, then you can use the exact formula that you use for k x to the power of n, which is basically 2x to the power of n plus 1, which is minus 2 plus 1 divided by minus 2 plus 1, correct? And that is equal to 2 x to the power of minus 1 divided by minus 2 plus 1 is minus 1, correct? And I mean, to really give the answer, you can just put that as the answer, or you can make it like even better, like 2 divided by or minus 2 divided by x, because x, if it goes down, it is x, and then I'm taking the minus 1 and putting it, so it's minus 2 divided by x, right? So that will be, and obviously again and again, I want to make sure we always put a plus c. I'm forgetting that. Okay, so that's all it is. So basically, what are they doing? They're trying to trick or get your understanding of, hey, what is that? What is that root of, or what is that something by something means, right? And if you can just remember your past arithmetic ideas, then you know how to solve it. Okay, so again, this is a 36-minute video, and I know that I have not solved all the problems, right? I would let you go for that. Then tomorrow I'll continue to solve some more of these problems, and all of these problems, I'm telling you, really speaking, they are all how to reduce things in algebraic terms. When it is a root of x, what does that mean, right? How will you solve something like a root of x? So those are kind of the things that's being asked here. There's nothing, no rocket science here, but except that, and then further down, there's some, given a curve, given something, they're asking you to solve further problems, and I'll continue to solve it, right? But for now, I think the video is dragging a little bit, so I'll stop it here, and then I will see you tomorrow. Okay, bye.